Hi, I'm Matt Cranston with SudburyTV, and welcome to The Old-Fashioned Way, a show that celebrates modern people who use archaic tools and technology to make things the same way our ancestors made them. I'm here at the historic Longfellow's Wayside Inn in Sudbury, Massachusetts, which has held its tavern's license continuously for over 300 years and was once owned by automaker Henry Ford. I'm here for their famous cornmeal muffins, which are made on site, of course. And I don't just mean the bakery downstairs. To see how they're really made right from the start, we need to head just down the road.
Past the Little Red Schoolhouse and the Martha Mary Chapel, just a hop, skip, and a jump from the Wayside Inn Grist Mill, so to speak, is Hop Brook Pond on the Sudbury-Marlborough border. It's there that I meet up with Wayside Inn Facilities Manager Mark Tripp.
How you doing, Matt? I'm Mark.
How you doing?
Good to meet you.
So, this is where it all begins.
Yep, this is where it begins. This is where the power is stored to power the grist mill. This is the upper mill pond, fed to us from our friends in Marlborough. The water gathers here at the dam.
A dam?
A dam. We're standing on a dam right now. It was built by Henry Ford in place of an older dam. The level of this water here is very important. We need a good storage of water here, a high water level. And we control that right over here. Inside the dam, there's a valve down here in this manhole.
And how do you control the water specifically that goes to the grist mill?
Right over here at the raceway.
The raceway. All right, let's head over there.
This is the upper raceway. It's where we take the water from the mill pond, which is a higher elevation. The water runs through the upper raceway here, traveling underneath to the grist mill. To control the speed of the wheel, I have to control the flow of the water, and I can do that just by lifting up on this pen board here.
So if we're going to be grinding some cornmeal later,
I'm going to want this water running.
all right, so you're going to have to do what? You're going to have to raise that up?
It's very simple to do it. Basically, I come on over here. There we go. Got a good bit of water going there. Water's flowing down here now through the raceway with a good velocity. We need that as it travels down about 300 feet to the grist mill. We can start turning the wheel.
How did this dam and raceway come into being?
Well, Henry Ford built it in 1929. It's the location of a former dam. This location had many mills along here, along this brook, Hop Brook. We still have stone here from the original Howe family colonial era mills. The Howes built the Wayside Inn and developed the area around here.
So why would Henry Ford build a grist mill?
Henry Ford was aiming to build a colonial village. That's why he built the Martha Mary Chapel. He brought in the old Sterling schoolhouse. He brought the cider mill down from New Hampshire and built the grist mill as the center of the whole project. Henry Ford was looking to build a working museum. He wanted to build the best. This is the Cadillac of grist mills. It's a Philadelphia-style grist mill with an overshot water wheel. And he chose the overshot water wheel for its power. Considerable more power coming from an overshot wheel than an undershot wheel, like most New England-style grist mills. An overshot wheel allows the water to run over the top of the wheel, considerably less resistance, better wearing. It really is by far a higher quality grist mill. Here we are at the lower raceway. Brings water down into the forebay. It's the deepest point here. On the forebay we have a sluice gate. The sluice gate is controlled by the miller inside. A large handle, he'll spin it open, control the water as it runs over the overshot water wheel.
Now that we know how the water gets from the pond to the mill, we can go inside and see how the water powers 100% of the grist mill's machinery. It's about time we meet the miller.
Hello.
Hi.
Hey, Matt. How you doing?
Great.
My name's Ben Walker. I'm the miller of the grist mill, and I'm looking forward to showing you around. I'm a longtime resident of Sudbury, 69 graduate in Lincoln, Sudbury, and I've been the master carpenter in all these buildings over the years.
Well, we would love to see how this works.
Well, why don't you come on in and have a look.
All right.
We enter the millstone floor, which is where the grinding stones are, but head past those down the stairs to the gear room, which contains the wheels, gears, and belts that drive the entire mill. There's also a DC generator, designed and installed by Thomas Edison, a good friend of Henry Ford who frequently visited the inn. It was meant to power the whole village, though it was never put into use. Ben Walker explains how the water becomes power.
Well, here we are in the gear room, and the power transferred from the water wheel to this larger metal gear to this smaller gear, which spins faster, and it transfers over to this middle-sized gear, I'm talking diameter, which has wood teeth, which allow it to have some flexibility, and if there's any malfunction, the wood will break, and that can be replaced easily rather than the steel. So that wheel turns. It turns that other belts down there. There's a large belt that goes to the third floor. Will turn a whole series of belts for different various reasons along the whole ceiling of the third floor. And it turns this shaft. This shaft transfers the power to the pinion gear, which turns the power 90 degrees. So the power goes from this horizontal to the vertical. And that's what turns the stone. So we go from the large wheel outside, the metal wheel, down to this size, which creates a 25-to-1 ratio on spinning the stone.
Before we grind some corn, I want to see the system of shafts, pulleys, and belts that power the grain elevator and bolting reels. We head up to the third floor, which is off limits to tourists, to see where the rest of the machinery resides. Ben gives us an explanation of this seldom seen yet critical part of the operation.
Okay, we're on the third floor of the grist mill, and one of the main aspects of any kind of water power system is this drive shaft driven by the gearing down below. From the water power transfers the power up to this shaft, and the belt right here, this large leather belt, drives it, and it moves these other belts to do anything one may want to do with a lathe or a bolting reel or a textile machine. But this type of setup was started in the late 1700s all the way through till the advent of electricity. This system right here was the main cog in the wheel that drove the American Industrial Revolution, which includes Lowell, et cetera, the textile mills. They had a lot larger scale, but this is very efficient, and that's what we see here, and we've got to make sure we have plenty of grease.
It's time to grind some corn, which, traditionally, used to enter the grist mill through the top floor.
This opening right here, this doorway, which seems to go nowhere, when the big sacks of grain and berries used to arrive from the fields to get cleaned, the oxen would bring them in a cart in the olden days, and they'd bring them up to the base of this on the ground. And we would attach it to a rope, which came up to a pulley up here, and with the power of the wheel and the belts, we'd able to engage a clutch, which would able to pull that grain sack right up, and then we just bring it in, and we were able to distribute it into a bin that would feed the millstone, which is on the millstone floor below. These bags are 50 pounds of cornberries, and which is basically dried kernels of corn. We open the bag up, and we pick them up. Here we go.
We've got 200 pounds of cornberries loaded in the third floor hopper, directly above the millstone seen here. Now we need to assemble all the necessary parts onto the stone to make it ready for grinding. But first, Ben tells us a bit about the stones themselves.
This stone here is a 2,500 pound French burr stone from the Normandy region of France. The French burr stone being one of the best and hardest granites in the world, which was brought here when the mill was built in 1929. The top stone is called the runner stone, and then the lower stone, which is fixed, is called the nether stone, which is in the floor, which allows this stone, the top stone, the runner stone, to spin at a 25-to-1 ratio to the water wheel. There's furrows, channels in the stone in a swirl pattern, and then the flat area is called the lands. And as this stone spins, when the berries go in, the lands grind against the furrows, and the furrows allow the meal to swirl out against this wooden what we call the tun, or Old English for a ton, cowling that goes over the stone and allows the meal to swirl out, hit the edge of the tun, and go down the chute. Before I set up my tun, which goes on top of here, I cannot see this space here when the tun's on top, so I raise it so I can see it. I raise it up enough where there's space enough for me to run some of the cornberries and wheatberries in there just by hand with a stick, and then I run some in here once it starts spinning, it will be stone on product. Stone on product and not stone to stone, obviously. This wheel right here disengages the pinion gear. So if I want to just run the wheel by itself, I disengage with this wheel. Okay, we're putting the tun over the stone in a designated spot to keep the wheel and the flour at bay. Bring over the horse, which has the shoe attached with adjustments here for the amount of berries that go in. All right, now we bring the hopper over, which will be right on top of the shoe, which allows the cornberries, wheatberries to go in, and I'm able to stop the flow right here with this, and this holds about 300 to 400 pounds of the product. This chute here allows me to get the product from the bin on the 3rd floor, which will hold about 500 pounds, more than this hopper. So I put that in there, and we just fix that in there, and there it is. And then I'm able to control the flow by this little paddle here, and there's another paddle up there. So now I can deliver some berries before I get the stone turning into the hopper. Once the berries are in the hopper, I adjust the shoe up and down with this turn buckle with the leather strap to make it so the berries get in here and they're just about ready to pour out. And then if there's an emergency stop for some reason, something gets out of whack, I just put this little string here so I'm able to pull that up and stop it immediately. Once I put the cornberries in the hopper here, there's about 200 pounds in here at the moment, and it will flow just by gravity down into the shoe, and the damsel will shake it loose, and I can adjust it here, but I don't want to put too much in until I get the wheel spinning. So I've got to turn the sluice gate on, and the water comes out of the forebay onto the wheel, and I got to put a bunch of water because now that wheel is under a load. It's under it's got to turn the stone, it's got to turn a lot of other things. So I've got to put a lot of water on it, and it'll turn, and then this will turn, and I have to make adjustments by lowering the stone with this to get the right combination. So this is the sluice gate, and this turns the water on to the overshot wheel, and I lift up the little ratchet here, and turn it clockwise to an area that I'm familiar with. It will let some water out. There we go. I'll lower the stone some. There we go. A little more berries. Use the stone as a brake here. Dial it in. The amount of berries coming out like about an inch around, basically. The wheat's different. Much smaller. So now it's a series of listening and to making sure that I kind of hear the right sound and that the speed is lower and that the stone is hard down. And to make sure that it's in a proper portion, I reach in here and see how we're doing on the grind. And now that's not bad at all. But of course, this gets sifted out upstairs where the cornmeal gets separated from the larger pieces bran. So that's good. The corn berries and wheat berries that are ground from the stone, they go around the tun and then they hit a hole in the floor right next to the stone, come down this chute and into the grain elevator. And it scoops up the flour and brings it all the way to the 3rd floor, the highest point in the building. And then as it comes through the augers, it gets pushed along. The product goes into this bolting reel, which has a screening over it, very similar to your screened-in porch insect screen, the kind of diameter. And that gets rolling around. What falls through, what gets sifted, is the finished product. That comes down into this area here where this auger here is spinning, and it moves it along into this chute, which goes down into the bins on the millstone floor, and that's finished product, which I can bag it. The brand, which is what gets sifted out, because the stone is not 100% accurate when it grinds, the brand goes down the end of the bolting reel, which is askew one way, drops off the end, and goes into another bin, of which I either regrind it in the stone or we feed it to the livestock. And here we are. This is the final resting stop in the mill for the sifting process, the cornmeal coming out of the bolting reel, and it's ready to go. So what I do is I fill these bags, which is with the bags they came out of, and there's 50 pounds that went in, but I fill them for 40. Helps the back, helps move them around. Take my 1830 scoop, and we fill it right up to 40 pounds, which I can basically feel. Close enough. Now there's 40 pounds. I tie this up with string, and I bring him down to Billy. Walk him right in. He goes through about 100 to 200 pounds a week, depending on the functions and what's going on.
And with our cornmeal ground, we head back to Longfellow's Wayside Inn, down the stairs, through the kitchen, and right to the bakery, where Bill the baker shows us how he turns our cornmeal into delicious corn muffins.
Good morning.
How you doing?
Good, thank you. I'm Bill. I'm the head baker here at Longfellow's Wayside Inn. I've been here for 17 years, and we're getting ready to do some production of corn muffins.
Well, we were just at the Grist Mill.
Wow, and you know what? We use their cornmeal every single day that they grind fresh. And we keep it in a cool, dry place, and then we bring it here, and then we mix up our muffins, and we set to go.
Well, let's get started.
All right.
So, to the cornmeal from the Grist Mill, you add other ingredients.
Yes, we do. We add sugar, we add powdered milk, flour, our baking powder, and salt. Now, once you've added all the dry ingredients together, it's not complete until you add the liquid. Here we have eggs, vegetable oil, and lastly, good old cold water. And now we're going to turn it on first speed. That incorporates all of the ingredients together. Then we let it run for about 10 minutes. We prime our pans with a spray of oil and flour.
Right?
And then we just simply scoop our muffins in.
With your hand. That's interesting.
With our hands. It's much faster, and it becomes very even.
So what's next?
We have to pop them in the oven.
Okay. And what do you set your oven to?
Our ovens are set at 325, and we put them in for 5 minutes.
Okay.
And then at that time, we turn them and we set them again for another 5 minutes. And at that time, we double check to make sure they're done, but they should be.
Okay. Well, can't wait.
All right. Now I'm going to double check to make sure that they're done. 2 minutes more. The timer's off. And now they're ready. You just can't beat them.
Oh, those smell great. I can't wait to go upstairs and try one. Thank you so much.
You're welcome, and thanks for stopping by.
Now that we've seen the entire process, there's just one last thing to do. Oh, thank you.
You're welcome.
Fresh from the bakery. Oh, that is good. You've got to come try these for yourself. And that's just for starters. The Wayside Inn has a full menu of old favorites and new delights. Well, that's going to do it for this episode of The Old Fashioned Way. Until next time, don't take any wooden nickels.